Welcome to our deep dive. And wow, have you given us something interesting to explore? We're going to be diving into how Amazon Redshift has been totally reinvented, like revamped to stay on top of things in the whole world of cloud data warehousing.
Yeah,
It's amazing to see how much it's changed.
it is. It is.
So we're focusing on a paper, it's an academic paper called Amazon Redshift Reinvented.
Oh, okay.
It's written by Nikos Armanatzoglu and a team from Amazon Web Services, so, they should know what they're talking
Lead
about.
from the source.
Right.
Yeah.
And it was presented at a big data conference back in 2022.
hmm
So we're going to be looking at the ins and outs of Redshift, like how does it perform, its scalability, can it really handle tons of data,
Right.
and how does it fit into the bigger picture of AWS?
That's really interesting. It's exciting to see how they've addressed user needs, especially those needs that are always evolving. Like,
Yeah.
how do you keep up with the demand for better performance and scalability?
Yeah, those are big challenges.
Huge. And then, making it work smoothly with all the other AWS tools, that's a whole other layer.
Right, it needs to play well with others.
Exactly.
Okay, so let's jump right in. The paper makes a big deal about Redshift's performance, especially the value for money.
The bang for your buck.
Exactly. How much performance do you get for what you pay?
Yeah.
And they have these benchmarks showing beating other cloud data warehouses. We're talking like up to 3 times faster.
Wow. 3 times.
Yeah, imagine processing your company's sales data, let's say, 3 times faster and for like half the cost.
That's a game changer.
Right. That's the power Redshift brings to the table.
I mean, that's the kind of efficiency every business is looking for.
Absolutely. So how do they achieve that level of performance?
Well, they've combined a bunch of, innovative techniques. Like, it starts with how they actually store the data. They use something called columnar storage.
Columnar storage. Okay, break that down for me. How does that work, and why does it make Redshift so fast?
Okay, so think of it like a huge spreadsheet, right?
I'm picturing it.
In traditional databases, you've got data stored row by row.
Right, like a regular spreadsheet.
But Redshift does it differently. It stacks the data by column, so it's more like organizing that spreadsheet vertically.
Okay.
Yeah, so when you run queries, those analytical queries, you're usually just looking at specific columns, not whole rows.
Right, I'm usually just looking for specific pieces of information.
So Redshift can zoom right in and grab just that data without wading through all the irrelevant stuff.
So it's like a laser focus on what you need.
Exactly. And that saves a ton of time.
Makes sense. But the paper also mentioned something called massively parallel processing, or MPP for short. It sounds like a team effort.
It absolutely is.
Yeah.
Redshift acts like a well-coordinated team.
Right.
It takes those big queries and the data, splits them up into smaller chunks, and then spreads them across multiple computers. It's like, imagine a team of chefs all working together to prepare a massive meal.
I see. So it's not just one chef trying to do everything, it's a whole team.
Right. Each chef handles a different part of the meal at the same time. So it gets done way faster than if one chef had to do it all alone.
So that's how Redshift crunches data so fast? It's like having a whole culinary team instead of just one chef.
Exactly.
Yep.
And on top of that, they don't stop there. They actually generate optimized code for each query.
Oh, wow. So they're really going all out for efficiency.
Right. They're like, we're going to skip the usual back and forth translation and go straight to the most efficient code possible. It's like a streamlined recipe for every data request.
I like that analogy, a streamlined recipe. So what else is in their bag of tricks?
Oh, they also use something called vectorized execution. That means they process data in batches using special instructions that modern processors are really good at. It's all about squeezing every bit of performance out of the system.
It seems like they've thought of everything. And, the paper mentions other cool features too, like this thing called prefetching. It almost sounds like they're planning ahead.
It is like prepping your ingredients beforehand.
Yeah. And then there's a dedicated service that makes the whole query process even faster. And get this, they even have efficient compression algorithms, so your data takes up less space.
Talk about efficiency.
Oh, and don't forget about AQA.
AQUA, what's that?
It stands for Advanced Query Accelerator. They're using special hardware designed for super fast calculations.
Wow, so they're not just optimizing the software, they're optimizing the hardware too.
Exactly. They're pulling out all the stops to speed up those complex queries.
That's really impressive. But, performance is just one piece of the puzzle.
Right.
What about storage?
Oh, yeah, that's a big one.
Because in today's world, data just keeps piling up. You need a system that can handle it.
Exactly. As your data volumes grow, you need a storage solution that can keep pace. And Redshift addresses this by using, Amazon S3.
S3. So they're using Amazon's cloud storage service as the backbone.
Precisely. It's like having this massive pantry for all your data.
But it's not just about dumping everything into S3, right? Right. Redshift also uses local SSDs on those compute nodes. Think of it like having a smaller, faster pantry for frequently used ingredients.
So you have the main pantry, S3, with everything in it.
Yeah,
And then you have this smaller pantry with the things you use all the time.
exactly. You get the best of both worlds. Huge storage capacity, A&D, super fast access.
That's smart. So who's managing all this? I mean, it sounds pretty complex.
That's where Redshift Managed Storage comes in, or RMS. RMS is like the brains of the operation.
Okay, the brains.
It automatically figures out what data needs to be prefetched and cached
Yeah.
to optimize performance. Imagine you have a super organized pantry chef who knows exactly what you need and when.
That's a great analogy. So RMS makes sure the data you need is right there, ready to go.
Exactly. It takes care of all the behind-the-scenes magic, so you don't have to worry about the details.
So it's not just about having storage space, it's about using it intelligently.
Precisely. RMS ensures your data is safe, available, and ready when you need it. And one of the ways it does that is by making sure all your data is also stored in S3, which is designed for incredible durability and availability.
So it's like having a backup pantry just in case something happens to the main one.
Exactly.
Okay, so we've talked about storage, but what about the processing power, the compute resources?
That's where things get even more interesting. Redshift has multiple options for scaling those compute resources, so you can adjust the processing power to match your needs. It's like being able to add more chefs to your kitchen when you need to cook a bigger meal.
I like that. So if I need more power, I can just add more, like add more nodes to the cluster.
Pretty much. It's designed to be quick and easy. They call it cluster size scaling, and it uses that elastic resize feature we talked about earlier.
Okay, it's all connected. But what about those times when there's a sudden surge in demand? Like when everyone's trying to run reports at the end of the quarter.
Oh, they've got that covered too. They have something called concurrency scaling. It's like having extra ovens that automatically turn on when you have a lot of dishes to cook.
I see, so it automatically adds more power when needed.
Exactly. Redshift spins up additional clusters to handle those spikes in demand, so everything keeps running smoothly.
So if my team suddenly needs to run a ton of reports at the same time, Redshift can handle it without slowing down.
Absolutely. And if you have different teams that need to work with the same data, but with different priorities, there's something called compute isolation.
Compute isolation.
Yeah, it lets you have multiple isolated clusters that all share the same data using this cool feature called data sharing.
Hold on, isolated clusters that share data? How does that even work?
It's like having separate kitchens that all pull ingredients from the same pantry. You get isolation and consistency at the same time.
Wow, I'm really starting to see how much thought has gone into Redshift's design. It's adaptable, efficient, and seems really user-friendly.
You got it. And speaking of user-friendly, let's talk about automation. One of Redshift's original selling points was simplicity, you know?
Yeah, I remember. They wanted to make data warehousing accessible to a wider range of users. It wasn't just for the big tech companies anymore.
Exactly. But now they're taking it even further. They're using machine learning to automate all sorts of tasks and keep things running smoothly. It's like having a sous chef who anticipates your needs and makes sure everything is prepped and ready to go.
Machine learning. So they're using algorithms that learn from data to make Redshift even smarter. Give me an example. What kind of automation magic are we talking about?
Okay, well, one example is automatic table optimization, or
Right.
ATO.
ATO, okay.
Remember we talked about columnar storage and how data is organized within Redshift?
Yeah.
Well, ATO helps Redshift figure out the absolute best way to organize your data. So it analyzes your queries and then recommends the optimal configuration for your tables. It's like having a perfectly organized pantry where the most commonly used ingredients are right at your fingertips.
So it's like ATO is taking the guesswork out of data organization. It makes sure everything is in the right place for those lightning fast queries we were talking about. Pretty slick. But what else? What other automation tricks does Redshift have up its sleeve?
Well, there's also automatic workload management, or auto WLM. Think of it as a kitchen manager who keeps everything running smoothly.
Okay, I can see that.
Auto WLM manages those queries, scheduling, and resource allocation. So it ensures optimal throughput and response times. It's like an air traffic controller for the Redshift world, making sure everything runs efficiently.
So even with a ton of activity, Auto WLM keeps things moving.
Exactly. And remember those materialized views we talked about earlier?
Yeah, those pre-prepared components that speed up query.
Right. Well, Redshift automates the creation, maintenance, and use of materialized views. It's like having a system that pre-chops your veggies and keeps those prepped ingredients fresh.
Okay, so Redshift is always working in the background, making sure everything is organized, optimized, and ready to go. I'm really starting to see how all these pieces fit together. But what about those inevitable bumps in the road? Like, what happens when a server crashes?
That's where their approach to cluster health and high availability comes in. They've got features like smart warm pools, which are like pools of pre-configured servers that are ready to jump in if a node fails.
So it's like Redshift has a built-in safety net, right? What else?
Well, they also have something called gray failure detection. It uses algorithms to spot those subtle performance issues before they become big problems.
Gray failure. That sounds a bit more complex than a simple system crash.
You're right, gray failures are those sneaky little issues that can be tough to pinpoint. But Redshift is designed to detect those subtle signs of trouble. It's like having a doctor who can diagnose a health issue based on really subtle symptoms.
So Redshift is being proactive about keeping things running smoothly. That's good to know. But what about those of us who don't want to deal with server management at all? Is there a way to make data warehousing even simpler?
Absolutely. They have something called serverless compute. It uses algorithms to completely automate the provisioning, sizing, and scaling of compute resources.
So I don't have to manage servers or clusters at all.
Nope, Redshift handles it all for you.
That sounds amazing. It's like data warehousing on autopilot.
You got it.
Eh,
And that brings us to the final piece of the puzzle. How does Redshift fit into the larger AWS ecosystem?
that's a great question. Because a data warehouse doesn't exist in a vacuum. It needs to connect to all these other systems and services to be truly useful.
Exactly. And Redshift embraces this philosophy of using the best tool for the job. It integrates seamlessly with other AWS services to give you a really comprehensive data warehousing solution.
I'm really curious about how Redshift handles data lakes because those are becoming super popular.
Right. Well, Redshift has this feature called Spectrum, and it lets you query data stored in open formats like Parquet and ORC right there in Amazon S3.
So I can access and analyze all that data in my data lake without even having to move it.
Exactly. It's incredibly efficient.
That's pretty incredible. It's like having instant access to a huge library of data. But wouldn't querying all that data in the data lake slow things down? I mean, we're talking about massive amounts of data here.
That's where Redshift's parallel processing comes in again. Remember that team of chefs we talked about?
Yeah.
Well, Redshift applies the same principle to data lake queries. It breaks them down into smaller chunks, distributes them across multiple nodes, and gets the job done fast.
So it's like having a team of researchers tackling a complex problem together.
Exactly. And this really highlights how adaptable Redshift has become. It can work with traditional tables, it can handle data lakes, it even works with that schemaless data we touched on earlier.
Right. It's not just a traditional data warehouse anymore. It's evolved into something much bigger.
You got it. Redshift embraces the reality that data comes in all shapes and sizes, from neatly organized spreadsheets to messy JSON files.
Speaking of messy JSON files, let's circle back to that super data type.
Oh yeah, super. The one that can handle those schemaless rebels.
Exactly. Data that doesn't want to fit into those neat rows and columns.
Super is like this flexible container that's ready to hold any kind of data. Structured or unstructured, doesn't matter. It's really handy for those ELT workflows.
Yeah.
Extract, load, transform,
ALT.
where you need to capture the data first and figure out its structure later.
So if I'm dealing with data from, say, social media feeds where the format is constantly changing,
That perfect example.
Super lets me capture it all without worrying about whether it fits a predefined structure.
Exactly. It gives you that safety net so you don't lose any valuable information just because it doesn't fit a particular mold.
I can see how that would be super helpful. But once I've got all this schemaless data in Super, how do I actually make sense of it? I mean, regular SQL queries might not work very well with unstructured data.
You're right. That's where Particle comes in. It's like the cooler, more adaptable cousin of SQL. It's designed to handle that free-flowing nature of semi-structured data.
Okay, so it's SQL, but with special powers for unstructured data.
Exactly. Particule lets you query and analyze data without needing to know the exact structure up front. It can handle nested data, arrays, even missing values.
So it's built for flexibility.
Exactly. It's very forgiving. And the best part is you can mix Particule with regular SQL, so you can seamlessly blend insights from both structured and semi-structured sources.
So I'm not limited to one or the other. I can use the right tool for the job depending on the data I'm working with.
You got it. And this is a great example of how Redshift has become more than just a data warehouse. It's really a platform, an ecosystem. It's not just about storing and analyzing data, it's about connecting the dots between different data sources and giving you the tools to work with data in all its different forms.
Yeah, it's a more holistic approach to data. But we can't forget about serverless computing and AWS Lambda.
Oh, right. Remember how Redshift lets you define those custom functions using code from Lambda?
Yeah, it's like having a way to run your own custom programs right within Redshift.
Exactly. And this integration unlocks so many possibilities. You can enrich your data, implement custom logic, even migrate legacy code, all without managing servers.
It sounds like Redshift is becoming more and more extensible. You can really customize it to fit your specific needs.
Absolutely. And with machine learning becoming so important, we can't forget about Redshift ML.
Right. We briefly touched on it before, but let's dive deeper. How does it actually work?
Redshift ML brings the power of machine learning right into your data warehouse. It makes it so much easier to build and use those machine learning models.
Okay, so how does it do that?
Well, it integrates really tightly with Amazon SageMaker, which is like the machine learning powerhouse of AWS.
So instead of moving data back and forth between Redshift and SageMaker, I can just work with everything within Redshift.
Exactly. It streamlines the whole workflow and makes machine learning so much more accessible. Imagine you're a marketing analyst who wants to predict which customers are likely to churn. With Redshift ML, you can train a model directly in Redshift using your existing customer data. No need to transfer anything.
And then I can use that model to score new customers and see who might be at risk of leaving.
Precisely. And because Redshift ML leverages SageMaker, you get all the benefits of SageMaker's advanced features. You have a choice of different algorithms, you can automatically tune your models, and you can even deploy those models for real-time predictions.
Wow, it sounds like Redshift ML puts the power of machine learning into the hands of everyday data analysts. You don't need a PhD in data science to use it.
Exactly. And that's really the goal, to make powerful tools like machine learning more accessible to everyone.
This is all incredibly impressive, but it's also a lot to take in. Where do I even begin?
That's a common feeling. I think the best place to start is by defining your goals.
Mhm.
What are you trying to achieve? What are your data challenges? Once you know that, you can start exploring how Redshift can help you.
So it's not about using every shiny new tool, it's about having a plan.
Right. And don't be afraid to experiment. Redshift has so many options for getting data in, analyzing it, and integrating with other tools. You'll figure out what works best by trying things out.
And Redshift is constantly evolving, right?
Absolutely.
Mhm.
New features are being added all the time, so it's important to stay up to date. Luckily, there are tons of resources available, documentation, tutorials, blog posts, even entire online communities. The AWS community is really helpful, so don't hesitate to ask for advice.
This has been an incredible journey. We've explored Redshift's evolution, how it works with other AWS services, and how we can build really powerful data-driven applications with it. I'm feeling inspired to dive in and experiment.
That's great to hear. And I have a feeling this is just the beginning of your Redshift adventure.
I think you're right.
There's so much more to discover.
Yeah. Welcome back to our deep dive into Amazon Redshift. Last time we talked about how Redshift delivers that incredible performance and can handle huge amounts of data. And we also got a sneak peek at those self-managing features and how it fits into the AWS ecosystem. You mentioned there's even more to explore about its integration with other AWS services. I'm all ears.
Absolutely. Let's pick up where we left off, with Redshift's ability to work with data from those busy operational databases, like DynamoDB and Aurora. Remember we talked about federated query?
Hmm.
It's that feature that lets Redshift reach right into those databases and pull the data it needs in real time.
Yeah, it sounded pretty magical. Like Redshift can just grab data from anywhere without breaking a sweat.
It is pretty slick.
Yeah.
But there's a little wrinkle we need to talk about. Different database systems sometimes use slightly different versions of the data language. Think of it like regional accents.
So a query that works perfectly in Redshift might sound a bit off to, say, DynamoDB.
Exactly. And that's where Redshift's built-in query optimizer comes in. It's like a skilled interpreter.
Oh, okay.
It understands the nuances of each database system,
Uh-huh.
and it figures out the most efficient way to translate your queries.
So it's making sure everyone's speaking the same language and preventing those data misunderstandings.
Precisely. It might even break a complex query into smaller parts, sending some to Redshift and some to the operational database. It's all about optimizing for speed and efficiency.
That reminds me of how Redshift uses that parallel processing to handle those big queries, like dividing and conquering.
You got it. It's all about efficiency. And speaking of efficiency, let's talk about glue elastic views, or GEV for short.
Okay, GEV. That was the other approach to integrating operational data. It was about those synchronized copies of data, right? Like a mirror image.
Exactly. GEV lets you define views over AWS sources like DynamoDB, and then you can create Redshift materialized views on top of those.
Yeah.
It's like building a bridge between the two that automatically keeps both sides in sync.
So I could have up-to-the-minute operational data available in Redshift without manually updating anything.
Precisely. GEV takes care of all that behind-the-scenes syncing. You can be confident that your Redshift views are always reflecting the latest data, no matter how often it changes.
That's amazing. So Redshift really is a master collaborator. It works seamlessly with these other AWS services to make data integration a breeze.
It truly is. And remember Spectrum, which lets Redshift connect directly to those massive data lakes on S3.
Yeah, we talked about how it lets you query data directly where it lives in the data lake. No need to move it around.
Exactly. Spectrum is a game changer for organizations dealing with huge data sets, especially in those open formats like Parquet and ORC.
Yeah.
It saves so much time and effort. Imagine you're a researcher with terabytes of climate data stored in S3. With Spectrum, you can analyze that data right from Redshift. No need to download or transfer anything.
It's like having your research lab connected directly to this vast library. So convenient. But wait, doesn't Spectrum rely on Redshift's processing power? Wouldn't running those huge queries on the data lake slow things down?
You're sharp.
Hmm.
But that's where Redshift's parallel processing comes in again. Remember that team of researchers we talked about?
Oh, yeah.
Redshift uses that same strategy with those data lake queries. It splits them into smaller parts, distributes them across multiple nodes, and boom, you get your results fast.
It's all coming together. So Redshift is this incredibly adaptable data platform. It can work with traditional tables, handle data lakes, and even work with that schemaless data we talked about.
You're absolutely right. Redshift has evolved way beyond the traditional data warehouse. It recognizes that data comes in all sorts of shapes and sizes these days, from neat and tidy spreadsheets to those messy JSON files. Speaking of which, let's circle back to that super data type.
Oh, yes. Super, the one that can handle all that schemaless data. Those data rebels that don't want to conform to rows and columns.
Exactly. Super is like this flexible container, ready to hold any kind of data, whether it's structured or unstructured. It's particularly useful for those ELT extract load transform workflows, where you might need to capture data first and worry about the structure later.
So if I have data coming from, let's say, social media feeds where the format is constantly changing,
Perfect example.
Super lets me capture it all without stressing about whether it fits a predefined structure.
Exactly. It's like a safety net that ensures you don't lose valuable information just because it doesn't fit neatly into a box.
I see. But once I have all this schemaless data in Super, how do I make sense of it? I mean, standard SQL queries might not be the best tool for that kind of data.
You're spot on. That's where Particle shines. It's like SQL, but designed to work with that free-flowing, semi-structured data like you'd find in Super.
So it's like SQL, but with superpowers for handling unstructured data.
Exactly. With Particle, you can query and analyze data without knowing its exact structure up front. It's designed to be flexible and forgiving, so it can handle nested data, arrays, even missing values.
So it's built to handle the messiness of real-world data.
You got it. And the best part is, you could even mix Particle with your regular SQL queries, so you can seamlessly blend insights from structured and semi-structured sources all in one go.
That's incredible. So I can use the right tool for the job depending on what kind of data I'm working with. I love that flexibility.
Exactly. This just shows Redshift's dedication to providing a truly comprehensive data platform. It's not just about storing and analyzing data. It's also about connecting the dots between your different sources and giving you the tools you need to work with data in all its forms.
It's not just about the individual features, it's about the bigger picture, right? It's like this unified data platform for the modern world. And speaking of modern, we have to talk more about serverless computing and AWS Lambda.
You're on a roll. Remember we talked about how Redshift lets you define custom functions using code from Lambda?
Yeah, it's like having your own little programs running right inside Redshift.
Exactly. And this integration opens up a world of possibilities. You can enrich your data, you can implement custom logic, you can even migrate legacy code, all without the hassle of managing servers.
It's like Redshift's secret weapon, letting you customize it and make it do exactly what you need.
It's pretty powerful.
Yeah.
And this extensibility just reinforces the fact that Redshift isn't just a data warehouse anymore. It's a full-blown extensible data platform.
Okay, so we've seen how Redshift can handle operational data. It can tap into those massive data lakes. It can even work with all that unstructured data. And it's all powered by serverless computing. Pretty amazing. But we can't forget about machine learning. It's such a powerful tool for extracting insights and making predictions.
You're absolutely right. Remember Redshift ML? We briefly touched on it before, but let's dive a little deeper. How does it actually work its magic?
I'm all ears.
Okay, so Redshift ML brings the power of machine learning right into your data warehouse. It makes the whole process of building and using those machine learning models so much simpler.
So, how does it do that?
It's all about integration. Redshift ML works hand in hand with Amazon SageMaker, which is like the ultimate machine learning platform on AWS.
I see. So, instead of moving data back and forth between Redshift and SageMaker, I can just do everything within Redshift.
Precisely. This just makes everything so much easier and streamlines the entire process. Imagine you're a marketing analyst and you're trying to figure out which customers are most likely to churn. With Redshift ML, you can build that churn prediction model right there in Redshift using your customer data. There's no need to move it to a separate platform.
And then I could use that model to evaluate new customers and see who might be at risk of leaving. That's powerful.
Exactly. And because Redshift ML is built on SageMaker, you get access to all those fancy SageMaker features, like the choice of different algorithms, automatic model tuning, and even deploying models for real-time predictions. It's like having a team of expert data scientists working for you behind the scenes.
It sounds like Redshift ML is making machine learning accessible to everyday data analysts. You don't need to be a data science whiz to use it.
That's the goal. Make those powerful tools available to everyone.
This is all incredibly impressive, but it can feel a bit overwhelming. Like, where do I even begin? There are so many possibilities.
That's a common feeling, don't worry. The best way to start is to ask yourself, what are you trying to achieve? What data challenges are you facing? Once you have a clear idea of your goals, you can start exploring how Redshift can help you reach them.
So it's not about using every single tool, it's about having a clear purpose.
Exactly. And remember, it's okay to experiment. Redshift gives you so many options for bringing data in, analyzing it, and connecting with other tools. The best way to learn is by trying things out.
And Redshift is constantly evolving, right? There's always something new to learn.
Absolutely. New features are being released all the time, so staying up to date is essential. But don't worry, there are tons of resources out there to help you. You've got documentation, tutorials, blog posts, and even online communities. The AWS community is incredibly helpful and supportive.
This deep dive has been amazing. We've explored Redshift's evolution, how it plays with other AWS services, and how it can be used to build these incredible data-driven applications. I'm feeling pumped to try it out.
That's the spirit. I think this is just the beginning of your Redshift journey.
Yeah.
As you start digging deeper and connecting those dots between your data sources, you're going to discover some pretty amazing insights and opportunities.
I can't wait. Welcome back to the deep dive. We've spent the last two parts exploring the world of Amazon Redshift, its impressive performance, how well it plays with the whole AWS family, and how it handles all sorts of data like a champ. But now, let's get down to brass tacks. How can all this Redshift power help you unlock possibilities in your own data work?
That's the fun part. We've seen Redshift connect to data lakes, chat with those busy operational databases,
Hmm.
even wrangle that free-form schemaless data. Now picture all that coming together for real-world applications.
Okay, let's get practical. First things first, how do we even get data into Redshift? I remember we talked about Spectrum letting you query data right where it lives in your S3 data lake. But what if you want to bring all that data into Redshift? Maybe for some serious analysis or to mix it up with other data.
Good point. It's like bringing ingredients from your pantry into the kitchen to create something amazing. Redshift gives you a bunch of options for that data ingestion process. You get your classic ETL tools, but you can also use AWS services like AWS Glue.
AWS Glue, yeah, that rings a bell.
Right. Glue is like your sous chef for data integration. It's a serverless service that can grab data from all sorts of places, clean it up, format it nicely, and load it right into Redshift for you.
So let's say I have customer data spread out across my data lake. I can use Glue to wrangle it all and get it ready for Redshift.
Exactly. Once it's in Redshift, you can really unleash its analytical power. Think, high performance queries, advanced functions, and even integrating it with machine learning tools like Amazon SageMaker.
Speaking of machine learning, we chatted a bit about Redshift ML earlier. How can that help build those real-world data-driven applications?
Let's say you're running an online store and you want to stay ahead of customers who might be thinking of leaving, churning. With Redshift ML, you can build a churn prediction model using all your historical data, and you can do it all within Redshift. Then, you can use that model to score new customers in real time and identify those who might be at risk.
So, as new customers sign up, Redshift can flag the ones who are likely to churn, giving me a chance to step in, maybe offer them a special discount or something to keep them around.
Exactly. And since Redshift ML works so well with SageMaker, you can take advantage of all those great SageMaker features. You get a whole bunch of different algorithms, automatic model tuning. You can even deploy those models to make predictions in real time. It's like having a whole data science team at your fingertips.
That's pretty incredible. But churn prediction is just the tip of the iceberg, right?
Yeah.
What else can I do with Redshift ML?
Oh, there's so much more. You can use it to detect fraud, find unusual patterns, personalize product recommendations. The possibilities are endless.
So, Redshift sounds like the ultimate tool for streamlining data work, building smarter applications, and getting more value out of your data. But with all these features and integrations, it's a little intimidating. Where do I even start?
I get it. It can be a lot to take in. The best approach is to figure out your goals first.
Yeah.
What are you trying to solve? What insights are you looking for? Once you have a good grasp of that, you can start exploring how Redshift can help you get there.
So, it's not about using every single feature, it's about being strategic.
Right. And don't be afraid to play around with it. Redshift gives you so many different ways to bring in data, analyze it, and connect with other tools. You'll figure out what works best for you by just trying things out.
And Redshift is always evolving, right? There's always something new to learn.
Absolutely. New features are popping up all the time, so it's important to stay in the loop. Luckily, there are tons of resources out there to help you. You've got documentation, tutorials, blog posts, even those online communities. The AWS community is incredibly helpful, so don't be shy about asking for advice.
This has been such an eye-opening deep dive. We've gone through Redshift's journey, its seamless integration with other AWS services, and how it can help build these amazing data-driven applications. I'm ready to jump in and get my hands dirty with Redshift.
That's awesome. I have a feeling you're going to achieve great things with Redshift. As you continue exploring and making those connections between your data sources, you'll find insights and opportunities you hadn't even imagined.
That's a great note to end on. Thank you so much for guiding us through this deep dive. I know our listeners must be feeling empowered and ready to unlock the full potential of Redshift.
It was my pleasure. The world of data is constantly changing, and Redshift is right there leading the charge. Embrace its power and let your data be your guide.
That's perfect. Thanks for joining us on the deep dive. Until next time, keep exploring, keep learning, and keep diving deep into the world of data.